Hey guys, Ramesh here. Welcome to my YouTube channel. In this video, we'll go through a few important Spring Boot interview questions and answers. So here we can see I have listed around 18 Spring Boot interview questions. So these are the questions that may appear in Spring Boot interviews, and each and every question I have explained with practical examples. Okay, so this video is quite lengthy. It is around 2 hours because each question or each concept I have explained with practical example. That's why you can see the video length is more than 2 hours. Okay, well, whenever you will give answer to these questions in interviews, make sure that you will also provide some practical examples or real-time use cases. So basically the interviewer will expect a practical answer from the candidate. Okay, so make sure that whenever you will answer to these Spring Boot questions in interviews, you will provide some real-time use cases. For example, let's say you have used some Spring Boot features in your Spring Boot project, so make sure that you will give a real-time that project related use cases or practical examples, so that interviewer will basically expect those kind of explanation from you. Okay, so in this video we'll go through these few important Spring Boot questions in detail with practical examples, like what is Spring Boot and what problems Spring Boot solves, explain few important Spring Boot key features, what is Spring Boot auto configuration, and how Spring Boot internally works, or explain run method in Spring Boot, what are the different ways to create a Spring Boot project, and explain these important annotations, and what is Spring Boot starters, and name few commonly used Spring Boot starter dependencies, what is Spring Boot starter parent dependency, how many types of projects we can create using Spring Boot, explain types of embedded servers in Spring Boot, and how to change default server port, and how to run Spring Boot application from the command line, and describe the flow of REST API request through Spring Boot application, and explain Spring Boot MVC application architecture, how to create and deploy Spring Boot WAR file to External Tomcat Server, what is Spring Boot DevTools used for, and how to add security in your Spring Boot project, and explain Spring Security Auto Configuration in Spring Boot project, and what is Spring Data REST used for, and how you use for files in your Spring Boot project. If yes, explain briefly. Alright, without further ado, let's go ahead and let's dive into these Spring Boot interview questions. Before understanding about what is Spring Boot, let's quickly take a look into what is Spring Framework. Well, Spring is a very popular Java framework for building web applications and enterprise applications, and Spring Framework made Java much easier for developing enterprise applications. Well, Spring is very popular for several reasons, like Spring's dependent injection approach encourages writing testable code, and it provides a powerful database transaction management capabilities, and Spring simplifies integration with other Java frameworks like Hibernate or Struts and other web frameworks, and Spring provides a WebMVC framework for building web applications as well as RESTful web services. Alright, so Spring is very popular for these reasons, guys, and Spring Boot is basically built on top of Spring Framework to basically reduce a lot of configuration required to set up the Spring based applications. Okay, so Spring Boot is basically an extension of Spring Framework, which eliminated the boilerplate configuration required for setting Spring based applications. Okay, Spring Boot is not it's not a different framework, guys. Spring Framework is just a extension of Spring Framework, and Spring Boot internally uses all the Spring Framework libraries. Alright, so apart from that, Spring Boot provides many key features. For example, Spring Boot provides Spring Boot starter dependencies, and Spring Boot provides auto configuration, externalized configuration, Spring Boot actuator, and easy to use embedded servlet container support. So these are the key features that Spring Boot offers. Okay, and the main goal of Spring Boot is to quickly create production-ready Spring-based applications without requiring developers to write the same configuration again and again. So in case of Spring Framework, we need to configure a lot of things, right? So consider we are developing Spring MUC application using Spring Framework without Spring Boot. Then we need to do a lot of configuration in Spring MUC project. Okay, so Spring Boot basically addresses the Spring application configuration problem. So Spring based applications have a lot of configurations, guys. So that is the main problem of Spring based applications. Okay, so if Spring application is huge, then we need to provide a lot of configuration in Spring based applications. Okay, and that is the problem the Spring Boot addresses. Okay, for example, when we use Spring MUC, we need to configure these details. For example, we need to configure component scan, dispatcher servlet, view resolver, web jars, among other things. And when we use Hibernate or JPA in our Spring based application, then we need to configure a data source, entity manager factory or a session factory, transaction manager, among other things. And let's say if we use cache in our Spring based application, then we need to provide a cache configuration. Let's say if we use message queue, then we need to provide a message queue configuration. Let's say if we use NoSQL database, then we need to provide a NoSQL database configuration, and etc, etc. All right, so we need to provide all these configuration in a Spring based applications. Okay, so this is the main pain for developers while developing Spring based applications, right? We need to configure a lot of things. So developers should have to focus on only the business logic, not on these external configurations. So this is the main problem of Spring based application developed using Spring framework. Okay, and Spring Boot addresses these problems. So what Spring Boot does is Spring Boot will automatically configure Spring MUC configurations like component scan, dispatcher servlet, view resolver, web jars, etc. whenever Spring Boot finds Spring MUC dependency in a class path. Okay, so Spring Boot, what it does, it will configure all these things for us whenever Spring Boot finds Spring MUC jar file in a class path. Similarly, whenever Spring Boot finds Hibernate dependency in a class path, then Spring Boot will automatically configure these details for us. Similarly, for cache, MQ, and NoSQL. So whenever Spring Boot finds NoSQL database related dependency in a class path, it will automatically configure NoSQL database configuration. Alright guys, Spring Boot solves a lot of problem that Spring developer basically face. So the main goal of Spring Boot is that as a developer you should only focus on business logic of your application, not on the not on other stuff. Spring Boot will provide a lot of features to automatically configure a lot of stuff. Okay, so the main goal of Spring Boot is to quickly create production ready Spring based applications without requiring developers to write the same configuration, boilerplate configuration again and again. Okay, so that is the beauty of Spring Boot. We don't have to write the same boilerplate configuration again and again. Okay, Spring Boot will automatically configure all the configurations for us whenever it finds a dependencies in a class path. So let's quickly take a look into these are the Spring Boot key features so that we will know more about Spring Boot. Okay, so Spring Boot is nothing but just an extension of Spring framework, and we can use Spring Boot to create a production ready Spring based application without requiring developers to write a same configuration code again and again. All right, great. So Spring Boot starters. Well, Spring Boot offers many starter modules to getting started quickly with many of the commonly used technology like Spring MUC, JPA, MongoDB, Spring Batch, Spring Security, Elasticsearch, etc. So these starter dependencies are pre-configured with most of the commonly used library dependencies, so you don't have to search for compatibility library versions and configure them manually. Alright, so these Spring Boot starters will take care of maintaining the compatible versions and all the configurations. For example, Spring Boot starter data JPA dependency. So this dependency, whenever we add in our Spring Boot application, then it will it will include all the dependencies required to use Spring Data JPA along with Hibernate library dependencies. Alright, so as a Hibernate is one of the most commonly used JP implementations, so Spring Data JP internally uses Hibernate as a JP provider. Alright, so Spring Boot provides this dependency, that is Spring Boot starter data JP dependency. We need to only add this starter dependency. It will internally include all the required dependencies to work with Spring Data GPA. Okay, so one more example is Spring Boot starter web dependency. So whenever we add Spring Boot starter web dependency in our Spring Boot project, it will by default pull all the commonly used libraries while developing Spring MVC applications, such as Spring MVC, Web MVC, Jackson JSON library, validation API, and Tomcat server. Alright, so Spring Boot will do a lot of things for us. We need to only add the starter dependencies. Okay, so this is about Spring Boot starters. Alright, now let's take a look into Spring Boot auto configuration. Well, what is Spring Boot auto configuration? Spring Boot auto configuration attempts to automatically configure your Spring applications based on the jar dependencies that you have added in the class path. Okay, so Spring Boot auto configuration, it automatically configures your Spring based application based on the dependencies or jar dependencies that you provide in a class path. Well, before exploring Spring Boot auto configuration, let's first take a look into why do we need Spring Boot auto configuration. So if you have already worked on Spring framework or Spring based applications, then you have seen that Spring based applications have a lot of configuration. Okay, so let me show you a Spring based application without Spring Boot. So look at here, this is Spring MVC Hibernate CRUD web application. So this is the project I have developed using Spring MVC Hibernate. Okay, I haven't used Spring Boot in this project, and you can find this project on my GitHub profile. So go to Spring MVC tutorial, and in this tutorial repository you can find Spring MVC Hibernate CRUD web application project. Well, in typical Spring MVC Hibernate project, we need to configure many things. For example, so this is a Java based configuration, and in application context configuration file you can see a lot of beans created manually. For example, session factory. If we use Hibernate in Spring MVC application, then we need to configure these three beans, that is session factory bean, data source bean, and then transaction manager bean. Okay, if we don't use Spring Boot, then we need to configure these three beans if we use Hibernate in Spring MVC. Okay, so this is in all the typical Spring MVC applications. Okay, these three beans should be configured. So apart from that, we are using a JSP or TimeLeap. For that, we are also need to configure view resolver, right? So that I have defined in WebMVC config class. So look at here, in this project I have used JSP, so I have configured internal resource view resolver for JSP. So this is a typical bin we need to configure when we use JSP or TimeLeap as a view layer. So apart from that, we need to configure dispatcher servlet. So there are different approaches to configure dispatcher servlet. Like either we can configure dispatcher servlet in web.xml, that is deployment descriptor, or we can configure dispatcher servlet using Java based configuration. Okay, so just understand, like without Spring Boot we need to configure these beans for Spring MVC project. So this is the typical configuration. Okay, you can develop any kind of Spring MVC application, and if you are using Hibernate, then you need to configure all these things. When we use Spring MVC, we need to configure component scan, dispatcher servlet, view resolver, web jars, and other things. And let's say if we integrate Hibernate or JP in our Spring MVC application, then we need to configure data source bin, entity manager factory or session factory bin, and transaction manager and other things. So these are the typical configuration in all kind of Spring MVC application. So we can automate these configuration, right? Because these configurations are almost available in all the Spring MVC application. I mean, in all kind of Spring MVC application we need to configure these things. Why not we automate these configurations? So instead of writing this configuration in all kind of Spring MVC application again and again, why not we automate these configurations? Well, Spring Boot team has comes with this new thought process. They have automatically configured all these configurations. So whenever Spring Boot finds Spring MVC dependency in a class path, then Spring Boot will automatically configure component scan, dispatcher servlet, view solver, and if we add Spring Data JPA or a Hibernate in a class path, then Spring Boot will automatically provide a data source bin, entity manager factory, or a session factory bin, and transaction manager. All right. So Spring Boot auto configuration basically configures all these configuration for us whenever Spring Boot finds Spring MVC dependency and Hibernate dependency in a class path. So this is the best example for Spring Boot auto configuration. So the next Spring Boot key feature is externalized configuration. So this feature is very useful whenever you want to deploy your Spring Boot application in different environments. So basically this feature enables developer to work with the same application in different environments. Environments can be a dev environment, QA environment, UAT environment, or production environment. Okay, so you can use properties file or YAML file, that is YAML file, to maintain the configuration. And Spring Boot basically offers different configuration file for different environments. Okay, you can maintain a different profiles for different environments. All right, and you can use annotations like add value annotation and add configuration property annotation to read the values from the properties file or YAML file into Spring Bean configuration. All right, so this is a very useful feature whenever you deploy your same application in different environments. Okay. So the next Spring Boot key feature is Spring Boot Actuator. So this is one of my favorite feature. Okay, so in our Spring Boot application we configure a lot of details. All right, and we need to monitor all these details, right? So Spring Boot Actuator provides a lot of REST endpoints to view the health check and the metrics. A lot of things we can view by using Spring Boot Actuator. So Spring Boot Actuator provides a wide variety of production-ready features without requiring developers to write much code. For example, we can use Spring Actuator to view the application bin configuration details. We can use Spring Actuator endpoints to view the application URL mappings, environment details, and configuration parameter values. And we can use Spring Actuator provided REST endpoints to view the registered health check metrics. Okay. So Spring Boot Actuator exposes a lot of REST endpoints to monitor a lot of configuration details, environment details, URL mapping details, health metric checks, a lot of things. All right, so this is a very cool feature that Spring Boot provides. Okay, great. The next Spring Boot key feature is easy to use embedded servlet container support. Well, this is a very cool feature. We can quickly run our Spring Boot application in an embedded servlet container. Okay, so traditionally when we build a web application using Spring Framework, then we need to deploy our Spring web application in external Tomcat server, right? So first we need to download the Tomcat from the internet, and then we need to set up the Tomcat server, and then we need to make a WAR file of our Spring MVC web application, and then we need to explicitly deploy WAR file in a Tomcat server. So these are the steps involved whenever we use Spring Framework without Spring Boot. All right, so Spring Boot made it very easier to deploy our Spring Boot application in an embedded servlet container. Spring Boot by default provides Tomcat server as a default embedded servlet container. And whenever we use Spring Boot starter web dependency, then it will automatically include Tomcat as an embedded servlet container. So whenever we run our Spring Boot application as a standalone, it will run in a default embedded Tomcat server on port 8080. We no need to create external var file and deploy an external Tomcat server. So we can make a jar file of Spring Boot application and we can run it as a standalone in embedded servlet container easily. Okay, so these are the key features that Spring Boot offers. Well, what is Spring Boot auto configuration? Spring Boot auto configuration attempts to automatically configure your Spring applications based on the jar dependencies that you have added in the class path. Okay, so Spring Boot auto configuration, it automatically configures your Spring based application based on the dependencies or jar dependencies that you provide in a class path. Well, before exploring Spring Boot auto configuration, let's first take a look into why do we need Spring Boot auto configuration. So if you have already worked on Spring framework or Spring based applications, then you have seen that Spring based applications have a lot of configuration. Okay, so let me show you a Spring based application without Spring Boot. So look at here, this is Spring MVC Hibernate CRUD web application. So this is the project I have developed using Spring MVC Hibernate. Okay, I haven't used Spring Boot in this project, and you can find this project on my GitHub profile. So go to Spring MVC tutorial, and in this tutorial repository you can find Spring MVC Hibernate CRUD web application project. Well, in typical Spring MVC Hibernate project, we need to configure many things. For example, so this is a Java based configuration, and in application context configuration file you can see a lot of beans created manually. For example, session factory. If we use Hibernate in Spring MVC application, then we need to configure these three beans, that is session factory bean, data source bean, and then transaction manager bean. Okay, if we don't use Spring Boot, then we need to configure these three beans if we use Hibernate in Spring MVC. Okay, so this is in all the typical Spring MVC applications. Okay, these three beans should be configured. So apart from that, we are using a JSP or TimeLeap. For that, we are also need to configure view resolver, right? So that I have defined in WebMVC config class. So look at here. In this project I have used JSP, so I have configured internal resource view resolver for JSP. So this is a typical bin we need to configure when we use JSP or TimeLeaf as a view layer. So apart from that, we need to configure dispatcher servlet. So there are different approaches to configure dispatcher servlet. Like either we can configure dispatcher servlet in web.xml, that is deployment descriptor, or we can configure dispatcher servlet using Java based configuration. Okay, so just understand, like without Spring Boot we need to configure these beans for Spring MVC project. So this is the typical configuration. Okay, you can develop any kind of Spring MVC application, and if you are using Hibernate, then you need to configure all these things. When we use Spring MVC, we need to configure component scan, dispatcher servlet, view resolver, web jars, and other things. And let's say if we integrate Hibernate or JP in our Spring MVC application, then we need to configure data source bin, entity manager factory or session factory bin, and transaction manager and other things. So these are the typical configuration in all kind of Spring MVC application. So we can automate these configuration, right? Because these configurations are almost available in all the Spring MVC application. I mean, in all kind of Spring MVC application we need to configure these things. Why not we automate these configurations? So instead of writing this configuration in all kind of Spring MVC application again and again, why not we automate these configurations? Well, Spring Boot team has comes with this new thought process. They have automatically configured all these configurations. So whenever Spring Boot finds Spring MVC dependency in a class path, then Spring Boot will automatically configure component scan, dispatcher servlet, view resolver, and if we add Spring Data JPA or a Hibernate in a in a class path, then Spring Boot will automatically provide a data source bin, entity manager factory, or a session factory bin, and transaction manager. All right, so Spring Boot auto configuration basically configures all these configuration for us whenever Spring Boot finds Spring MVC dependency and Hibernate dependency in a class path. So this is the best example for Spring Boot auto configuration. Okay, so Spring Boot brings in a new thought process, like can we bring a more intelligence into this? When Spring MVC jar is added into an application, can we auto configure sim bins automatically? Okay, so how about auto configuring a data source bin if Hibernate jar is on a class path? How about auto configuring a data dispatcher servlet if Spring MVC jar is available in a class path? So this is the thought process of Spring Boot team, and they came with this auto configuration feature, like whenever Spring Boot finds Spring MVC jar dependency in a class path, then automatically configure dispatcher servlet, view solver, and other stuff. Alright, this is a very important concept in Spring Boot, guys. Try to understand Spring Boot auto configuration. So just remember, Spring Boot auto configuration attempts to automatically configure your Spring applications based on the jar dependencies that you added in a class path. And this is the best example, like whenever you add a Spring MVC in a class path, then Spring Boot will automatically configure component scan, dispatcher servlet, view resolver, and if you add Hibernate or Spring Data JPA, then Hibernate then Spring Boot will automatically configure data source bin, entity manager factory bin, transaction manager, etc. Let's understand the step by step how run method internally bootstrap our Spring Boot application. This diagram shows Spring Boot application execution process. Well, we have a main method, right? So inside a start class, that is Spring Boot main entry point class, we have a main method. So this main method is same as like the normal Java program we use, right? And we define a main method to run the Java program, and main method the execution of the program, Java program, starts from the main method, right? Similarly, in Spring Boot application, the execution of the Spring Boot application starts from the main method, and it internally called a run method, and all the logic have been written in a run method to bootstrap Spring Boot application. So bootstrap in the sense, run method will load all the auto configuration classes, and run method is responsible to execute all the auto configuration classes, and it create the Spring IOC container, and it return the Spring IOC container. That we'll see step by step. Okay, look at here the steps. Spring Boot application execution start from the main method, and the main method internally call Spring application dot run method. Okay, main method internally call Spring dot run method, and Spring application dot run method performs a bootstrapping for our Spring Boot application. So this is a very important. The run method internally load all the auto configuration classes, and it creates the Spring IOC container. It will trigger the listeners, trigger the runners, etc. Okay, bootstrapping means it will load all the necessary configuration and components required to run our Spring Boot application. And next step is it will start stopwatch to identify time taken to bootstrap the Spring Boot application. So we need a timer to calculate the time taken by our Spring Boot application for bootstrapping, right? So that that is done by stopwatch class, and then it will prepare an environment to run our Spring Boot application. The environment can be a production environment, dev environment, test environment, QA, UAT environment, etc. Okay, if you configure any environment in application.properties file, then run method will prepare environment for that. And next it will print the banner. For example, if you run the Spring Boot application, let me quickly run the Spring Boot application. So look at here, this is nothing but your banner. Okay, So once it will start the stopwatch, then it will prefer the environment and then it will print the banner. Okay, this banner. You can customize the banner or you can disable the banner mode. And then it will start the IOC container. So if you don't use Spring Boot, then we have to manually start the application context or Spring IOC container, right? But Spring Boot will take care of starting Spring IOC container or application context. Alright, so in Spring Boot we can see three types of projects: a default project, web servlet project, and reactive project. This we'll talk in upcoming videos. Just take a note, like run method internally start IOC container based on the class path. Okay, and refresh context. So once it will start the IOC container, then it will refresh all the context and it will load all the necessary components, and then it will trigger the runners. For example, in Spring Boot we have two kinds of runner: application runner and command line runner. So these runner we basically use to execute our logic only once during our application startup. So just remember these runners, and we use these runners in our application, Spring Boot application, in this course to execute our logic. Like if we want to save some records in a database, then we can use command line runner to run our database related logic only once during application startup. And then run method will basically return application context object. Application context is nothing but our Spring IOC container. Alright, so these are the steps involved in Spring Boot application execution process. Now we will deep dive into the source code of run method and we will understand all these steps. Okay, so let's switch to our Spring Toolsuit ID. Let me stop the server. Okay, so all our Spring Boot application execution start from this class. So this is called start class or Spring Boot application entry point class. So this class contains a main method, and main method internally called Spring application dot run method. So look at here, run method is a static method and we are calling run a static method using a class name. We are not creating object of this class to call a run method, because run method is static, so we use class name to call the run method. A run method takes two arguments: first argument the start class name, and then command line arguments. Okay, great. Now let's jump into run method and look at here. Now we are in Spring application dot class, and this class contains a run method, and look at here, run method is a static method. Okay, a run method internally call another run method, so there are overloaded static run methods. Okay, and again this run method internally call a run method, and there we go. So this is the run method which contains all the steps. For example, the first step is stopwatch starts, and if you look at the source code of run method internally starts a stopwatch to calculate the time taken by our Spring Boot application. Okay, understood? So this is the line of code. Okay, run method internally starts stopwatch to calculate the time taken by our Spring Boot application, and it will declare configurable application context object. So this is nothing but our Spring IOC container object. This is not yet created, this will be created in next step. Okay, and it will get all the listeners. Okay, and then it will start all the listeners. So these are the Spring Boot application level listeners. Okay, whatever the command line argument that we pass to run method, that will be passed to this get run listeners method. Okay, so first step is starting stopwatch, and next preparing the environment to run our Spring Boot application. And here is the logic which will prefer environment for our Spring Boot application. If you go inside prefer environment, then you can able to see all this source code. So this source code is responsible to create the environment. Okay, so based on the web application type, it will create the environment. All right, so at a post, at a post time, you may not able to understand the source code, but just try to understand the steps. What does the run method does behind the scene. So once it will prepare the environment, the next step is it will print the banner. Okay, look at here, print banner. Next step, it will create the application context. It means it will create the Spring IOC container. If you go inside create application context, so look at here, it will create the application context. If you go inside create method, and if you can see that it will create the application context or IOC container based on the web application type, whether the application is a web application or a reactive application or a default application. Just remember, run method internally starts IOC container. So if you don't use Spring Boot, then we need to manually start the application context. Okay, next step is it will refresh the application context, and then it will stop the watch, and then it will call the runner. It will trigger the runners. If you go inside call runners, it has two types of runner, application runner and command line runner. So whatever runner we use in our Spring Boot application, that will be triggered here. Okay, great. After that, it will return a context. Context is nothing but a configurable application context object. Okay, so configurable application context is an interface. It internally extends application context, and application context is nothing but our Spring IOC container. Okay, understood? So let me revise the steps. So run method internally call stopwatch.start method to just calculate the time taken by our Spring Boot application. Then next it will prefer the environment, and next it will print the banner. Next it will create the application context, and then it will refresh the application context, and then it will stop the watch, and then it will call all the runners, or internally it will trigger all the runners, and then it will return application context object. Okay, understood? So very important, guys. You should understand how Spring Boot application bootstrap behind the scene. Well, you can see here, these are the three simplest ways to create Spring Boot project. So the first way is using Spring Initializer. Alright, so first way is using Spring Initializer, and second way is using Spring Starter project in Spring Tools Suite IDE. And you can install Spring plugin in Eclipse IDE, and you can get option to create a Spring Boot project in Eclipse itself. Okay, this is the second way. And third way is using Spring Boot CLI. Okay, this is a command line interface which you can use to create Spring based project. Alright, so Spring Boot CLI is a command line tool that you can use if you want to quickly develop Spring application. Okay, now let's quickly take a look into how we can create Spring Boot project using these three ways. So the first way is using Spring Initializer. Well, look at here, start.spring.io. So this is the URL for Spring Initializer. Spring Initializer nothing but a website which we can use to quickly create Spring based application. So this is the basically a standard way to create a Spring Boot project. And you can integrate this Spring Initializer in any IDE by using plugins. Okay, just remember, this is the standard way, guys. This is standard way to create a Spring Boot project using Spring Initializer. Alright, so you can use this URL start.spring.io to access Spring Initializer, and you can go ahead and you can create Spring Boot project. Alright, great. So this is the first way, and second way is using Spring's starter project in STS IDE. Well, let me show you this step how we can create Spring Boot project in Spring Tools Suite IDE. So go to Spring Initializer, So go to Spring Tool Suite ID, and in order to create Spring Boot project in Spring Tool Suite ID, go to File, New, and then Spring Starter Project. Okay. Alright, so look at here, this is the Spring Initializer website URL. Alright, so Spring team has integrated Spring Initializer in Spring Tool Suite ID itself. Alright, so if you want to use Spring Initializer, then what you need to do is, there are a lot many manual steps, right? You first need to create a Spring Boot project from this Spring Initializer, and then you need to generate the project as a zip file, and then you need to unzip it, and then you need to import in IDE. So these are some manual steps, and it takes some time, right? It consumes some time. So instead of doing this, Spring team has integrated Spring Initializer in Spring Tool Suite ID itself, so that we can quickly go ahead and create Spring Boot project in Spring Tool Suite ID itself. Okay, so this is the second way. And the third way is using Spring Boot CLI. So Spring Boot CLI is basically a command line tool that you can use if you want to quickly develop Spring applications. Okay, so first you need to install the Spring Boot CLI. You can install Spring Boot CLI manually by using SDK man manager. Alright, and you can use these commands to quickly create Spring Boot project using Spring Boot CLI. So these are the three simplest ways to create a Spring Boot project. We will understand one important annotation, that is add Spring Boot application annotation. So this is a very important annotation, and it does a lot of things while running our Spring Boot application. Okay. Alright, and this annotation should be annotated for our Spring Boot application starter class or Spring Boot main entry point class. Okay, this annotation should be annotated for this starter class. Okay, and now if you can go inside this source code of this annotation, you can see this annotation internally contains three annotations. First is Spring Boot application, Spring Boot configuration annotation, enable auto configuration, and component scan annotation. Alright, add Spring Boot application annotation internally contains these three annotations. Alright, let me show you in a diagram. So look at here, add Spring Boot application annotation is the combination of add Spring Boot configuration annotation plus add enable auto configuration plus add component scan annotation. And add Spring Boot configuration annotation internally uses add configuration annotation. So let me show you in a source code. So look at here, this is the add Spring Boot configuration, and it internally uses add configuration annotation. Okay, so understood. Just remember, Spring Boot application annotation, it internally contains these three annotations. Now let's understand these three annotations step by step, so that you will be able to understand the usage of Spring Boot application annotation. Okay, as we know, Spring Boot configuration annotation internally uses add configuration annotation, so this annotation should work as add configuration annotation. Now let's understand the usage of add configuration annotation. So this is very important annotation, and we use add configuration annotation to configure, to provide a configuration as Java-based configuration. Okay, Java-based configuration. So there are three types of configuration we can do in a Spring-based application, right? One is XML-based configuration, all right, and second is Java-based configuration, and third is annotation-based configuration. Okay, so in order to do Java-based configuration, we use add configuration annotation. So basically we create a Java class, and then we annotate that Java class with add configuration annotation, and then that Java class becomes a configuration class, and we can define all the Spring related configuration in that class. For example, let's say I can create a class over here For example, let's say spring config. Okay, so this is a normal Java class. Okay, it doesn't related to spring. Now what we can do, we can use add configuration annotation on top of this class, so that this class becomes spring Java based configuration class. Alright, now we have annotated this class with add configuration annotation, and now this class becomes a Java based configuration, and we can define a beans, or we can configure beans inside this class. Okay, understood the usage of add configuration annotation? So we use add configuration annotation to make a Java class as a spring Java based configuration class, and we can define the beans inside this configuration class. So next is add enable auto configuration class. So this annotation is very important. This annotation enables auto configuration classes for our Spring Boot application. So whenever our Spring Boot finds Spring Starter web dependency in a class path, then this annotation basically enable a dispatcher servlet auto configuration class, view resolver auto configuration class, and other auto configuration classes. So this annotation is responsible to enable auto configuration classes whenever our Spring Boot application will find dependencies on a class path. Okay, just remember this annotation. And next is add component scan annotation. So this annotation is also very important, guys. So we use add component scan annotation to scan the Spring components in a particular package. For example, look at here, this is the project structure of our Spring Boot application, and this is called a base package for our Spring Boot application. Let me create one more package. Let's say .sub1, and let me create quickly one more package. Let's say .sub2. Okay, and as we know that this entry point class, that is Spring Boot application entry point class, annotated with add Spring Boot application annotation, and it internally contains add component scan annotation. Okay, now what this annotation will do is it will automatically scan all the Spring components inside this base package plus its sub packages. Okay, alright, so add component scan annotation will scan all the Spring components within a base package plus all the packages, the sub packages inside this base package. A demo is the base package, and within a demo we have sub1, sub2. So these are the sub packages of demo package, right? And add component scan annotation will scan all the Spring components present in demo package as well as sub1 and sub2 package. So Spring component means the class which is annotated with Spring provided stereotype annotations. For example, let me quickly create a class. Let's say Spring component, and I will create a method here, public string, let's say get message, and I will return some string here. Let's say hello world. Okay, so this is the class. It has a method, get message method, and this is not a Spring component yet. Okay, we need to annotate this class with some Spring provided stereotype annotation. For example, let's say if we use add component annotation. So whenever we add component annotation to any class, then this class becomes Spring component. Okay, and this add component scan annotation will scan this component, okay, during our application startup, and then it will scan and then it will register this component in Spring application context or Spring IOC container. Alright, I hope you understood the flow. Now what we'll do, we'll get this bin, this Spring component bin from the application context. So component, let me rename this. Okay, so go to our Spring Boot main entry point class. It has a main method and this is run method. So run method returns application context, right? That is configure application context, and this is nothing but a Spring IOC container. It contains all the Spring components. Now let's go ahead and let's get that application context from the run method. Configurable application context, and let's say application context. Okay, now what we'll do, Spring component equals to application context, and then we have a get bin method. So whenever you want to get a bin, that is Spring bin, then you can call get bin method, and there are overloaded get bin methods, so you can choose appropriate. So I'm going to choose first one, and then I will just pass Spring component here dot class. Now we got Spring component from the application context. So here application context is nothing but our Spring IOC container, and Spring IOC container contains all the Spring beans, and Spring component is nothing but a bin. Okay, because we have annotated this Spring component with add component annotation. Okay, so this is the annotation based configuration. So now what I'm going to do is I'm going to put the sys out here, and I'm going to call get message method. Now let's run the Spring Boot application and let's verify whether we have configured this component properly or not. So look at here, hello world. It means that add component scan annotation successfully scanned the sub package. Okay, I hope you understood the usage of add component scan annotation. So add component scan annotation basically scan the base package. Along with that, it will also scan all the sub packages for Spring components. So here we have a Spring component or Spring bean, and it is present in a sub1 package, and sub1 package it is stored in a base package. So this is the hierarchy. Alright, I hope we understood the usage of add configuration annotation, add enable configuration annotation, and add component scan annotation. Once we understood add configuration annotation, add enable auto configuration annotation, and add component scan annotation, then let's go back to add Spring Boot application annotation. So as we know, add Spring Boot application annotation is a combination of these three annotation. So instead of using these three annotation, we can use this single annotation, that is add Spring Boot application annotation. That's why whenever we create a Spring Boot application using Spring Initializer, by default Spring Boot will add this annotation to starter class or Spring Boot entry point class. Okay, so instead of using these three annotations, we can use this single add Spring Boot application annotation. And so this single annotation will do the purpose of these three annotations. Okay, I hope you understood the usage of add Spring Boot application annotation. So this is a very important, and just remember what this annotation does behind the scene. So it will auto configure the class as a Java configuration class, and it will enable the auto configuration, and it will scan the components in a base package as well as its sub packages. Okay, great. Well, Spring Boot starters is an important feature provided by Spring Boot, and we'll first take a look into what is the problem and then what solution the Spring Boot starters features provides. Well, probably you have already worked on Spring based applications, right? So I'm talking about developing Spring based application without Spring Boot. Okay, so when we develop Spring based application, then we need to maintain a lot of configuration, we need to maintain a lot of dependencies, right? So managing the dependencies in complex Spring based application is really hard. For example, look at here. So these are the dependencies. So whenever we develop Spring MUC application, then we need to add these three dependencies, right? Spring Web MUC, Spring ORM, Hibernate validator for form validation, and this is only a simple Spring MUC development dependencies. So whenever you develop Spring MUC application and if you want to use Hibernate, then you need to add a couple of Hibernate dependencies along with these Spring MUC dependencies. And if you want to use other dependencies, for example, if you want to use view layer, that is JSP or TimeLib, then you need to add a couple of dependencies. Okay, so basically whenever we develop Spring MVC application, then we need to add a lot of dependencies, guys, and we have to maintain the compatible version. Okay, let's say if we are using Spring MVC application with Hibernate, then we need to maintain a compatible version between Spring and Hibernate framework, and if we are using other third-party libraries, then we need to maintain a compatible version. Okay, so this is really hard, right? And developers sometimes spend a lot of time on hunting these dependencies and maintaining the compatible versions. All right, so this is exactly the developer were facing the issues. Okay, and the Spring Boot starters were built to address exactly this problem. Okay, well, this is the problem and the solution can be like this. So whenever we know that these are the dependencies required to develop a Spring MVC application, then why not we have a single dependency which will manage all these dependencies internally. Okay, so basically Spring Boot starters has provided a starter dependency, that is Spring Boot starter web dependency, and this dependency internally manages all these three dependencies with their compatible versions and other transitive dependencies. Alright, so Spring Boot starters are a set of convenient dependencies that we can include in our application. For example, so this is the Spring Boot starter dependency, that is Spring Boot starter web dependency. So whenever we want to develop Spring MVC application or whenever we want to develop Spring REST API application, then we need to add only this dependency. We don't have to add all these dependencies. Okay, so this is the problem that Spring Boot starter solves. So this is a very simple example. So whenever you want to develop other applications like reactive application, Spring reactive application, or if you want to use Hibernate, or if you want to use other Spring Data JPA, all right, so we need to maintain a lot of dependencies, right? And we need to maintain a compatible version. So that is where the Spring Boot developed the feature Spring Boot starters. So Spring Boot team has created a starters. So we need to only add the starters. So Spring Boot will internally take care of adding all the dependencies, required dependencies and their compatible versions. Okay, so let's jump into our IDE and let's understand more about Spring Boot starters and how we can see what is there inside these Spring Boot starters. So go to pom.xml. Okay, and here you can see Spring Boot starter web dependency. So this is basically Spring Boot starter dependency, and if you want to see what this Spring starter dependency contains, then you can just click on it. Okay, and here you can see the version, and then you can click on this and you can see what this starter dependency contains. For example, this starter dependency contains Spring Web dependency, Spring Web MVC dependency. Okay, along with that, Spring Starter Web dependency also provides a Tomcat server as a default web container. Along with that, it will add all the Jackson dependencies for us. Okay, so look at here, Jackson dependencies. Alright, so this is a really awesome, right? We don't have to add all these dependencies, guys. Okay, we don't have to add Spring MVC related dependencies. We don't have to download and install Tomcat server starter dependency automatically provides a Tomcat server to deploy the application as a standalone. We don't have to provide the JSON libraries. Okay, starter dependency will provide us JSON dependencies, and starter dependency will manage the compatible versions. Okay, so that is the beauty of Spring Boot starters feature. Okay, so it does a lot of stuff behind the scene. We don't have to maintain dependencies, guys. Spring Boot starters take care of adding all the dependencies and other related third-party dependencies and their compatible versions, etc. So this is a very simple example for Spring Boot starter web dependency. Similarly, if you can look Spring Boot starter test, so whenever we want to write a JUnit test cases, then we need to add a lot of dependencies, right? For example, JUnit 5 and Mockito and other dependencies. So if you go inside this starter dependency, you can see it uses all the JUnit related dependencies. So look at here, it internally uses JUnit Jupyter, okay, that is JUnit 5 dependency, and it internally uses Mockito dependency. So what are the popular dependencies that are required to develop a JUnit test cases? That this Spring Boot test starter dependency will include that. Okay, Hamcrest. So awesome, guys. We don't have to really add these dependencies, and we don't have to maintain their compatible versions. Okay, so Spring Boot starter test dependency will take care of all this stuff. So these are really important starters, guys. So just take a look into it. Okay, this Spring Boot starter web dependency. So this starter dependency we use to develop Spring MVC application as well as Spring REST application. And Spring Boot starter test dependency we use to write a JUnit test cases. We can use a JUnit 5, we can use Mockito, we can use Spring unit testing annotations, a lot of stuff. Okay, and apart from that, few more very important dependencies, like you can just copy paste and you can just change this string. Here I can say Spring Data JPA. So whenever you want to use Hibernate and Spring Data JPA in your project, then you can add this Spring Boot starter dependency. You don't have to add Hibernate dependencies manually, because this starter dependency will take care of adding Hibernate internally. Okay, great. So look at here, it adds Hibernate core dependency here. Okay, we don't have to add manually Hibernate core dependency and their compatible version. So this starter dependency will take care of adding all the dependencies. So apart from this, if you can see the Spring security, you can just change here Spring Boot starter security. Okay, and if you want to see what it contains, then you can go ahead and you can see what are the dependency it provides. Okay, you can see here Spring security web, Spring security, okay, config, Spring AOP. Okay, whenever we want to use Spring security in our Spring MVC application, then we need to add all these Spring security dependencies, right? And we need to maintain all the versions. Okay, so instead of adding all these dependencies, Spring Boot starter, Spring Boot team provided Spring Boot starter, that is called Spring Boot starter security. So we can use this single dependency to have a Spring security in our Spring based applications. Okay, so just remember, Spring Boot starters are nothing but starter dependencies that contains a set of convenient dependency descriptors, and they maintain all the versions, so we don't have to hunt for the compatible versions of the dependencies. Okay, so it's awesome, guys. Really, the developer were facing a lot of issues while developing Spring based application, and maintaining the dependencies, its compatible versions. So this Spring Boot solve that problem. Okay, we don't have to maintain the compatible version, we don't have to add all the required dependencies. We just need to add a single starter dependency, and we will get a one-stop shop of all the dependencies that are required to develop a particular functionality. For example, if you want to develop Spring MVC, then go ahead and use Spring Boot starter web dependency. If you want to use Hibernate in Spring project, go ahead and use Spring Boot starter data JPA dependency. If you want to use Spring security, then go ahead and use Spring Boot starter security starter dependency. If you want to use unit testing or JUnit test case, then you go ahead and use Spring Boot starter test dependency. So these are the starter dependency that we frequently use in our projects. Okay, just remember these starter dependencies. So apart from this, Spring Boot provides 30 plus starters, okay, to work with other different technologies to develop other different applications. Okay, so this is all about Spring Boot starters. Basically, whenever you create a Spring Boot application using Spring Initializer, then Spring Initializer will add this dependency as a parent dependency for your Spring Boot application. And this parent dependency basically provides a default configuration for your Spring Boot application. Now the question is, what default configuration? Well, if you go inside this dependency, you can see that Java version here. Okay, within a property section you can see Java version. By default the Java version is 1.8. so this Spring Boot starter parent dependency provides a default version for Java, that is 1.8. so if we don't specify Java version while creating Spring Boot project, then this parent dependency will provide a Java version 1.8 as a default Java version. Okay, and the question is, I want to use Java 16, which is the latest release. Then how can I do it? Well, you can override this property and you can specify whatever the Java version that you want. For example, so look at here, I can specify a properties section here, and within that I can override a Java versions section, that is Java version property, and I can specify whatever the Java version that I want. For example, I want JDK or Java 16. Okay, so this is how I can override and I can specify Java version that I want. Okay, but if you remove this, then Spring Boot starter parent will provide a Java version that is default 1.8. okay, so this one. All right, so this is the flexibility, guys. So whatever Java version you want to use, you can just go ahead and you can override this property and specify the Java version that you want. But if you don't specify, then by default it will provide 1.8. okay, so this is one default configuration. And other default configuration, you can see the plugins. Okay, so it provides a lot of Maven plugins, guys. Okay, we don't have to add a Maven plugins in our Spring Boot application. So this Spring Boot starter parent will provide a lot of Maven plugins that is required for our Maven project. All right, so Spring Boot starter parent dependency will provide a default Java version as well as the Maven plugins. Apart from that, it will also manage the version of all the dependencies. For example, if you can dive into this dependency, and you can see here the properties section, and within properties you can see the dependencies versions. Okay, ActiveMQ version and Cassandra version. Okay, and if you want to see the Hibernate, you can go ahead and you can see the Hibernate version over here. All right, Hibernate version, Hibernate validator version. Okay, HTTP core version. All right, so all the versions has managed by Spring Boot starter parent. We don't have to manage the versions over here, and these are the default versions, guys. Okay, and we can override and we can provide our own versions. Okay, that flexibility Spring Boot starter parent provides. All right, Spring Boot starter parent dependency, it provides a default Java configuration and Maven plugins, as well as it will manage the default version for the dependencies. And apart from that, one more very important very important feature that Spring Boot starter parent provides is that if you can just go ahead and you can observe the starter dependency versions here: Spring Boot starter web, JPA, security and test. So these starter dependencies don't have the version, right? Then how the versions maintained for these Spring Boot starter dependencies? Well, this is maintained by Spring Boot starter parent dependency. Well, whatever the version that we have specified to Spring Boot starter parent, so this version by default added to all these starter dependencies. Okay, we don't have to manually add this version here. Okay, we don't have to manually add the version for these starter dependencies. All right, so Spring Boot starter parent will take care of adding these versions for these starter dependencies. Okay, so let me show you how this added. So if you can go inside Spring Boot starter web dependency, you can see the version here. Okay, so this is how Spring Boot starter parent will add the version for all the Spring Boot starter dependencies. Alright guys, so this is the importance of Spring Boot starter parent dependency. Alright, it provides a default configuration for your Spring Boot application, and we can override the default configuration even in our Spring Boot application. Alright, I hope you understood the importance of Spring Boot starter parent dependency. There are three kind of project the Spring framework will create. For example, look at here, these are the starter dependencies: Spring Boot starter, Spring Boot starter web dependency, Spring Boot starter web plugs. So these three dependencies are very important guys, and Spring Boot framework will create three kinds of projects based on these three dependencies. We can create a Spring Boot application with Spring Boot starter dependency to develop the utilities and the standalone applications or the desktop based applications. Okay, because Spring Boot starter dependency does not contain the embedded Tomcat server or any other web servers, so we can use this dependency to create a standalone applications. And Spring Boot starter web dependency, so we can use this dependency to create a Spring MVC web application or Spring MVC REST API applications. And Spring Boot starter web plugs, so this dependency we can use to create reactive applications. Okay, Spring Boot web reactive applications. Well, as we know that Spring Boot application comes with a default embedded web server, that is Tomcat server. Alright, so it's a very important feature guys. We no need to download and install a web server or application server on our machine. Okay, so Spring Boot provides a very important feature, that is embedded server. So Spring Boot application comes with a default web server, that is embedded web server, that is called a Tomcat server. Okay, and basically Spring Boot application supports three very popular embedded servers. First is Tomcat, second Jetty, and then third is Undertown. Okay, by default Spring Boot comes with Tomcat server, and if you want to use Jetty or Undertown, then you need to exclude Tomcat dependency from your Spring Boot application, and then you need to add Jetty or Undertown dependency to your Spring Boot application. Okay, then you will able to run your Spring Boot application in an embedded Jetty or Undertown web server. Okay, that we will see bit later. Just try to understand embedded servers in a Spring Boot application. Okay, three types of embedded servers: Tomcat, Jetty, and Undertown. Now we have talked about a lot about embedded server, right? So what exactly is embedded server? So whenever we have a Java application and then we include a server as a part of that Java application, that is called embedded server in a Java application. Okay, so traditionally how we deploy our Java application, so we typically download Tomcat server from the internet, and then we'll install that Tomcat server in our machine, and then we package our Java application as a WAR file, and then we deploy that WAR file in an external Tomcat server, and then we start the server. So this is how we basically deploy our WAR file in a Tomcat server, right? Let's say if we include that Tomcat server as a part of our Java application, then the Tomcat becomes embedded Tomcat server in our Java application. Okay, so let me show you the diagram here. So look at here, these are the steps when we deploy our Spring Boot application without embedded server, and these are the steps when we deploy our Spring Boot application with an embedded server. Let's first consider if we don't use embedded server, then these are the steps. First step is we need to install the Java, and then we download and set up a web server. Consider we have a Tomcat server, and then we need to package our Spring Boot application as a WAR file, and we explicitly deploy our WAR file in a web server, that is Tomcat server. So these are the steps typically we do whenever we deploy Spring Boot application without embedded server. Okay, so look at here this step. So these steps take some time, right? We need to download and set up a web server. Okay, so instead of downloading and setting web server on our machine, why not we include this server as a part of our Java application? So that will be better and that will save our time, right? Okay, and instead of deploying this war file explicitly in a web server, then why not whenever we package our application, then why not we run simply this package as a Java application? So we can also remove this step. Okay, so whenever we include server as a part of Java application, then we can remove these two steps. Okay, so here is the result. So whenever we deploy our Spring Boot application with embedded server, then we can skip these two steps. Okay, so we need to have only installed Java. After that, we package our Spring Boot application as a jar file which already contains an embedded server, and simply we run the jar file as a normal Java application. That's it. We don't have to make a war file. We don't have to explicitly copy that war file in a web apps folder of the Tomcat server and then explicitly we need to start the Tomcat server. So we don't have to do in case of embedded server. Okay, so this will simplify a lot, right? So that's why Spring Boot comes with a feature that is embedded server. Okay, Spring Boot application by default comes with an embedded server, that is a Tomcat server. Okay, Tomcat server. And if you want to have a Jetty or Undertown server in your Spring Boot application as an embedded server, then you simply need to remove this Tomcat dependency and then you need to add a Jetty or Undertown dependency. Okay, so that we'll see a bit later. Okay, I hope you understood what is the embedded server and how we can include that embedded server in a Spring Boot application. Well, whenever we include our server as a part of Java application, then we call it as an embedded server. Okay, just try to understand the concept. Now let's understand more about embedded servers. So let's jump into IDE, and now I will show you how the Spring Boot application comes with default web server, that is Tomcat server. Go to pom.xml and here we have a dependency, Spring Boot starter web dependency. So this dependency internally provides default Tomcat as a embedded server. So let me show you. So just dive into this dependency and again go to inside this dependency, and here you can see Spring Boot starter Tomcat. Okay, so we don't have to add this dependency to our pom.xml because this Spring Boot starter web dependency internally provides a Tomcat dependency. Okay, so whenever we add Spring Boot starter web dependency to our project, then this dependency will provide a Tomcat server as an embedded server by default, guys. We don't have to add Tomcat dependency again. Okay, so let me jump into this dependency. So look at here, Spring Boot starter Tomcat, and if you go inside this dependency you can see Tomcat dependencies. Okay, so whatever the Tomcat source code that you have in a Tomcat server, that source code is available with these dependencies. Okay guys, so by looking into these dependencies you can see that by default Tomcat server is a part of Spring Boot application, and whenever we run our Spring Boot application, then Spring Boot application will run in this Tomcat server as a standalone. Okay, we don't have to explicitly download and install the Tomcat server. Spring Boot comes with a default web server, that is Tomcat server. Okay, so let's go ahead and let's run the Spring Boot application and let me show you how our Spring Boot application will run in an embedded Tomcat server. So look at here, our Spring Boot application is running in a embedded Tomcat server. Okay, embedded Tomcat web server which is running on port 8080. By default the Tomcat server will run on port 8080, but you can customize this port. Okay, you can give any port that you want, so you need to provide that port by using some property. So you can go to application.properties here and you can define the properties something like server.port. Okay, by using this property you can just change the Tomcat server port. By default it is 8080. Now you can go ahead and you can give 8081 or whatever the port that you want. Okay, great. So this is how the Tomcat server comes with Spring Boot application as an embedded server. Now the question is, I don't want to use embedded server. I want to use other embedded server like Jetty or Undertown. Then how I can configure Jetty or Undertown as an embedded server in our Spring Boot application? Well, let me show you how to do it. So go to pum.xml, and this Spring Boot starter web dependency, it internally provides a Tomcat dependency, right? So we have to exclude that dependency from this Spring Boot starter web dependency, and then we need to add separate Jetty or Undertown dependency. Okay, so in order to do that, just call here the tag exclusions, and inside that add the dependency exclusion Tomcat. Now we have excluded Spring Boot starter Tomcat dependency from Spring Boot starter web. Now we can able to add other embedded servers, for example Jetty or Undertown. Now let me show you first how to add Jetty as an embedded server. So let me quickly copy this dependency and paste it here. Okay, let me remove this scope, and here instead of test we can just add Jetty here. Okay, that's it. Now let's go ahead and let's run our Spring Boot application in embedded Jetty web server. So go to our Spring Boot main entry point class, right click, run as Spring Boot application. Now instead of running our Spring Boot application in embedded Tomcat server, now it will run in an embedded Jetty server. So look at here, embedded Jetty web server, and by default Jetty server will run on port 8080. But we can able to customize this port. Okay, you can change this port by adding the property in application.properties file. So you can add a property called server.port, and here you can specify the port 8081 or any port that you want. Okay, by default the port is 8080. Let's say we provide a port 8081. Okay, now if you stop the server and if you run the Spring Boot application, then you can able to see that Spring Boot application should run on a Jetty web server on port 8081. So look at here. So this is how you can change the port. Okay, now we'll see how to add Undertown server as an embedded server. So go to pum.xml again. Okay, and here we have earlier added Jetty, so we just replace from Jetty to Undertown. Okay, Undertown. So in order to run our Spring Boot application in embedded Undertown server, again go to our Spring Boot main entry point class, right click and run as a Spring Boot app. Okay, and let's see. Yeah, there we go. Our Spring Boot application is running on Undertown web server on port 8081. So the port 8081, because we have added a port 8081, right? So let me remove this, and if you can run Spring Boot application again, then the Undertown server will run on port 8080. And there we go. Our Spring Boot application is successfully running on embedded Undertown web server on port 8080. Alright guys, this is how we run our Spring Boot application on different embedded web servers. Okay, we have seen how to run our Spring Boot application in a Tomcat server, Jetty server, and Undertown server. So during development, we spend a lot of our time in IDE, and we run our Spring Boot application from main entry point class, okay, which has a main method, right? So whatever the IDE you use, for example, you may use IntelliJ IDEA, Eclipse, or NetBeans. So you have to run your Spring Boot application using Spring Boot starter entry point class, which has a main method, right? So sometimes the developer may want to run Spring Boot application from outside the IDE, and one option for that is using command line. Okay, you can use a command line to run your Spring Boot application from outside the IDE. Alright, so as we know that Spring Boot application, whenever we run as a standalone, Spring Boot application will run in an embedded Tomcat server. So we just have to run our Spring Boot application as a standalone. It will automatically deploy in an embedded Tomcat server. We don't have to download the Tomcat server from the internet. We don't have to install Tomcat server in our machine. Okay, great. So there are two options to run our Spring Boot application from the command line. So one option is using java-jar command, and another option is using Maven plugin. Okay, so in this video I am going to show you both the options. So before running our Spring Boot application as a standalone in a command line, one more very important point is, if you look at the project structure of our Spring Boot application, here we have two files. Okay, these two files are called Maven wrapper files. Okay, so what these files will do, if we don't install Maven in our machine, then whenever we run our Spring Boot application using these commands, then Spring Boot application will automatically install a Maven for us by using these files. We don't have to install Maven and set up on our machine. Okay, so if you have already installed Maven, then you don't have to use these two files. You can simply delete these two files from your project. Okay, so in this video what I'm going to do is I'm going to use these two wrapper packages. Okay, so now what we will do, we will head over to this project in a file system. Okay, and open command line in this folder. Just type cmd and hit enter. So this will open a command line in your project, and here we're going to use mvnw. Okay, just look at here, mvnw. So this is the wrapper file that we are using to package our Spring Boot application as a jar file. Okay, so if you have already installed Maven in your machine, then you can simply use mvn. Okay, so this is the Maven shell. So I am assuming that you haven't installed Maven in your machine. Okay, so I am using mvnw. This is a Maven wrapper, and then just type package. So this will package your Spring Boot application as a jar file. So notice that our Spring Boot application is successfully built. Okay, and here you can just type dir. You can able to see the folder structure, and then just navigate to target folder, and here just type dir, and here you can see Spring Boot first app. Okay, so this is the jar file that we are going to run our Spring Boot application as a standalone. Alright, so in order to run this jar file as a standalone, just type the command java-jar followed by this jar name. Just copy it and paste here. So make sure that you have installed Java, because we are using Java command here. Alright, so go ahead and just hit enter. So this will run our Spring Boot application as a standalone in an embedded Tomcat server. So look at here, our Spring Boot application is up and running, and it is running in embedded Tomcat server on port 8080. Great, so this is the first option. Now let us see the second option. Second option is using Maven plugin. Okay, so in order to run our Spring Boot application using Maven plugin, just type the command mvnw. So again here we are using Maven wrapper file. Okay, Maven wrapper command here. So if you have already installed Maven, then you can simply use mvn followed by the plugin name. But I am assuming that you haven't installed Maven, so I am using mvnw here. Okay, I have followed by spring-boot:run. So this is the Maven plugin command that we are going to use to run our Spring Boot application as a standalone in embedded Tomcat server. So go ahead and hit enter. So it says mvnw is not recognized. So we are in a target folder, so we no need to go back to one folder. So here I am just enter the command mvnw spring-boot, okay, :run. Okay, make sure that you are in a project folder. Okay, so earlier I was in a target folder, that's why I got this error, but make sure that you are in a project folder. Okay, because this mvnw wrapper file is present in this project folder. Okay, now go ahead and hit enter. So look at here, our Spring Boot application is running in embedded Tomcat server, which is running on port 8080. Okay, so this is a very important, guys. Whenever we develop a real-time project, sometime as a developer we need to run our Spring Boot application from the command line. Let's take a look into Spring Boot project architecture. So this is a pretty simple Spring Boot project architecture. We call basically it as 3-layer or 3-tier architecture. Okay, so this is a 3-layer or 3-tier architecture, and this is a widely used architecture in Spring based applications. All right, so look at here, this architecture contains controller layer, service layer, DAO or repository layer, and each of these layers have their own responsibilities. For example, controller layer basically process all the requests that's sent by the client. Okay, and controller layer is also called API layer because we define all the REST APIs inside a controller layer. In Spring based applications, we typically create a controller and we define all the REST APIs in the controller. Okay, the REST API can be get REST API, post, put or delete REST API. Okay, so just remember, controller layer is responsible to process the request. Request can be get request, post, put or delete request. Controller layer is also called API layer. Okay, next come to service layer. Service layer we basically create to maintain all the business logic. So whenever you have a business logic in your application, then make sure that you will create a service layer and you keep all your application level business logic in a service layer. So apart from business logic, if you have any third-party REST API call or any public third-party REST API call in your application, that logic you can keep in a service layer. Okay, just remember, whenever you have business logic in your application, make sure that you will create a service layer. Okay, and you keep all the business logic in a service layer. Next come to DAO or repository layer. Well, DAO or repository layer is responsible to talk with the database, and in this course we are going to use MySQL database. Well, DAO layer or repository layer holds all the database related logic or persistence logic. Okay, so these are the 3 layers that we are going to create in our Spring Boot application. And again, in a controller we call a service, and in a service we call a DAO or repository. So basically in Spring based applications we inject service class or service interface in a controller, and we call service class methods in a controller. Similarly, in service class we basically inject a repository or a DAO, and then we call DAO or repository methods in a service class. Okay, so these 3 layers are independent to each other, and then we'll inject the dependencies and we call its methods. Now let's take a look into Spring Boot MVC project architecture. So this is the standard architecture that we are going to follow to develop our Spring Boot application, and this is the 3-tier or a 3-layer architecture. It has a controller layer, service layer, a repository or a DAO layer. Okay, this is a widely used architecture in project development. So basically controller layer holds all the Spring MVC controllers, and service layer basically holds all the service classes. It has a business logic, and the repository or a DAO layer holds all the persistence or a database related logic, and repository DAO layer is responsible to talk with MySQL database. So this is the 3-layer architecture. Now let's come to Spring MUC architecture. So look at here, this is the MUC architecture, or you can say MUC design pattern. We have a controller, view, and there is one more component called model. So controller is basically responsible to process the request, and it will return model and view to the browser to render the page. So controller layer basically process the request, and it will get the data from the database by using service and repository layer, and that model data basically bind to view, and that generates a web page. That web page will be displayed on a browser. It's pretty simple Spring MUC architecture. So sometimes the use case is like, let's say if you want to deploy our Spring Boot application in application server, for example JBoss wildfly server. Okay, in this case we need to generate our Spring Boot application as a WAR file, not a jar file, right? So in such scenarios we need to package our Spring Boot application as a WAR file, and then we need to deploy in an external server. Server can be a Tomcat server or JBoss server, right? So in this video we are going to take Tomcat as an external server. Okay, what we'll do, we'll package our Spring Boot application as a WAR file, and then we'll download Tomcat server from the internet, and then we'll deploy that Spring Boot WAR file in a Tomcat server. Okay, great. So let's head over to Spring Tools.id and let's quickly create Spring Boot project. So in order to create a Spring Boot project, go to File, New. Okay, go to Other and choose Spring Starter project here, and just give name as Spring Boot WAR Demo. Okay, just give project name as Spring Boot WAR Demo, and then choose Maven and choose packaging as a WAR. Okay, so this is very important, guys. Whenever you want to deploy your Spring Boot application as a WAR file in external Tomcat server, then you have to choose packaging as a WAR. Okay, so don't choose jar. So if you choose jar, then you need to deploy your Spring Boot application in an embedded Tomcat server as a standalone application. Okay, so now we are going to deploy our Spring Boot application as a WAR file in an external Tomcat server. Hence we need to choose packaging as a WAR over here. Okay, then Java version choose 16, and then language Java, and keep group as com.springboot.app, and then artifact is same as project name, and then version description, let's say Spring Boot WAR demo, something like this. Okay, and packaging as a com.springboot.war, something like that, and go ahead and click on next, and keep Spring Boot version default as it is. And then here we are going to choose Spring Web dependency. Okay, so if it is not available over here, then you just need to type Spring Web dependency. Okay, so go ahead and choose Spring Web Starter dependency and go ahead and hit finish. So this will create a new brand Spring Boot application in Spring Tools.id. Okay, now what we'll do, we'll add a simple REST endpoint in order to test our Spring Boot application deployment in external Tomcat server. So before that, let me clarify a few points here. Go to pom.xml, and here you can see packaging as a WAR. Okay, so make sure that the packaging should be WAR. We have selected WAR as a packaging type, right, while creation of Spring Boot application. And if you can see here, Spring Boot Starter Tomcat dependency with scope provided. So whenever you choose packaging type as a WAR, then this dependency will automatically add it to your Spring Boot application, because Spring Boot Starter Web dependency internally provides embedded Tomcat server, right? And whenever we want to deploy our Spring Boot application as a WAR file in external Tomcat server, then we need to add this dependency with scope provided. And one more important point is, go to source folder, and you can see here servlet initializer. So whenever you choose packaging as a var, then these three differences you can typically see. So first is packaging as a var, and then this Tomcat dependency with scope provided, and servlet initializer. So this class is needed to deploy our Spring Boot application as a var file in an external Tomcat server, because this class internally contains a servlet related file. For example, if you go inside this, and you can see here Spring Boot context loader, and then context loader listener, and you can see servlet context listener. So this listener is required for our Spring Boot application in order to deploy in an external Tomcat server or any other service, right? Whenever you create Spring Boot application with packaging as a var, then typically you see these three changes. Okay, packaging as a var, and then Spring Boot starter Tomcat dependency with scope provided, and servlet initializer class. Okay, and rest of the things remain same. Okay, so just try to understand when you choose packaging as a jar and when you choose packaging as a var file. All right, great. Now what we'll do, we'll simply create one REST endpoint here. I'm going to create a REST endpoint in this class itself. Let me add a annotation here, that is a REST controller annotation, and let's quickly create a simple REST API here, public, and this REST API should return a string, and let's give a name something like greeting. All right, and I'm going to annotate this method with @getMapping annotation, and just give REST endpoint URL something like greeting. Okay, and just return Spring Boot var demo, something like that. All right, so very simple REST endpoint. We are not going to create a standard REST API here. We just wanted to test our Spring Boot application deployment in an external Tomcat server. That's why we are going to just write a simple REST API here. Okay, great. Now what we'll do, we'll package our Spring Boot application as a var file. For that, right click on the project, run as Maven build. Okay, and here just type clean install. Okay, and go ahead and apply and run. So look at here, the Maven build is success. All right, and go to the project again. So let me minimize this. So go to project, right click and refresh. Okay, and then go to target folder over here, and within a target folder you can see Spring Boot var demo.var file. All right, so this is the var file generated whenever we build our Spring Boot application successfully. Okay, great. Now we are going to deploy this var file in an external Tomcat server. So for that, first we need to download and set up Tomcat server. For that, what I'm going to do is I'm going to go to browser here, and let's say download Tomcat 9. Okay, and go to first link, that is tomcat.apache, and here I'm going to download this zip file over here. Okay, once Apache Tomcat zip file downloaded on your file system, go ahead and open your folder, and now let's unzip it. Right click and extract. Alright, now you can see here web apps folder. So we are going to copy our var file and paste in a web apps folder. So go ahead and copy this var file from the target folder. Okay, and go to web apps folder and just simply paste it here. Alright, so once we copy paste a var file in a web apps folder, then go back to Apache Tomcat folder, go to bin here and search for startup file. Okay, so make sure that you choose Windows batch file here. So go ahead and double click on startup. So this will deploy our Spring Boot application in a Tomcat server. Okay, let's wait a couple of seconds. Now you can see here our Spring Boot application is up and running in an external Tomcat server on port 8080. So look at here. Now what we're going to do is we're going to test our deployment. Right, we have developed one simple REST API, right? Greeting REST API. So we are going to test this REST API from the browser, so that will make sure that our Spring Boot application deployment in external Tomcat server is successful. We'll go to the browser and in a new tab just type localhost 8080, and if you try to call this greetings REST API with this URL, it will give you an error, not found, because we have deployed our Spring Boot application in external Tomcat server, right? So we have to use this application context. Okay, this is this application name. Let me copy this application name, that is var file name, and go to browser, and if you try to add this application name here and then slash greeting, this will give you a result. Okay, so make sure that whenever you deploy your Spring Boot application as a var file in external Tomcat server, then make sure that you will give your the application context name. Okay, that is var file name, and then followed by REST API URL name, that is greeting. Alright, let me quickly recap what we have done in this video. We have created a Spring Boot application with packaging type as a var. Okay, and then we have created one simple REST endpoint to test the setup, and then we have packaged our Spring Boot application as a var file, and the var file is created under target folder. And then what we have done, we have downloaded a Tomcat server from the internet, and we have downloaded on our file system, and then we unzip, and then we have copy pasted var file in a web apps folder, and we have simply started the Apache Tomcat server, and we have tested the REST API. That's it, right? Very simple steps, guys. Let's first understand what is a developer problem and why developers should have to use Spring Boot DevTools dependency while developing Spring Boot project. Well, the problem is whenever we develop Spring Boot application, we do a lot of changes, right? And let's say if we do some changes in our Spring Boot application, then we need to restart our Spring Boot application. Then only the changes will get reflected, right? And this is kind of a tedious process, right? So developer need to restart the application again and again whenever he do some changes, right? So that is kind of a tedious process, and the solution could be application should be restarted automatically whenever we do some changes in our Spring Boot application. So that is what the Spring Boot DevTools dependency will solve the problem. Okay, the solution for this problem is Spring Boot DevTools dependency, right? For example, let's say we are developing Spring Boot first application project, okay, and we have added some REST endpoints to this project, for example hello world and some student related REST endpoint. Okay, and let's say if we deploy our Spring Boot application in an embedded Tomcat server, so typically we go to start class, that is Spring Boot entry point class, and we run as a Spring Boot application. So this will run our Spring Boot application in an embedded Tomcat server. Okay, great. Now our Spring Boot application is up and running on embedded Tomcat server. All right, now we can able to test our REST APIs. For example, let's say we are testing a hello world REST API here. Okay, so whenever we hit this URL, we get a response. Okay, because our Spring Boot application is up and running in an embedded Tomcat server. Now we want to make changes to our Spring Boot application. Consider we want to add one more REST endpoint. For example, let's say I will simply add one REST endpoint here. Let's say hello world, app, something like this. To just give you an idea, I'm going to just simply add one REST endpoint, something like this. And if we save, okay, so look at here, server is not restarted automatically. And if we try to call this REST API from the browser, for example, hello world app, so this will give an error, because whenever we do some changes in our Spring Boot application, we have to restart our server, right? For example, here we need to stop the server, okay, and we need to again start our Spring Boot application. Right click, run as Spring Boot app. So once our Spring Boot application is up and running in embedded Tomcat server, which is running on port 8080, now we can go ahead and we can call this REST API from the browser. Now we can get the response because changes are reflected. Okay, so whenever we do changes like this, we need to restart our Spring Boot application, then only the changes will get reflected, right? And this is kind of a tedious process, so developer don't want to restart the application again and again. Okay, so there should be a solution. The solution could be, there should be an automated process. Whenever we do some changes in a Spring Boot application, the server should be restarted automatically. Okay, so this is what the problem the developer faces, and Spring Boot provided the feature that is Spring Boot DevTools feature. So this feature or a module basically solve this problem. Okay, so basically Spring Boot DevTools dependency will detect our changes in our project, and based on that it will restart the server. The server can be in other servers, like right now we are using embedded Tomcat server, but if you are using Jetty or Thundertown, same process will apply for these servers as well. Okay, so whenever we do some changes in our project, then Spring Boot DevTools dependency will automatically restart the underlying server. The server can be Tomcat server, Jetty server, or Undertow server. Okay, now what we'll do, we'll use Spring Boot DevTools dependency in our project, and we'll verify how Spring Boot DevTools dependency will automatically restart our application whenever we do some changes. Okay, great. So let me stop the server here. Okay, and go to pom.xml, and here we need to add Spring Boot DevTools dependency. So in order to do that, I'm going to copy this dependency and I'm going to paste it here. Okay, and here I will just make a changes. So I will remove Spring Boot starter web, and here I will just add Spring Boot Dev Tools. So this is the dependency that we are going to use to restart our Spring Boot application automatically whenever we do some changes. Okay, now once we add this dependency, that is Spring Boot DevTools dependency, then what we'll do, we'll start our Spring Boot application. So go to main entry point class, right click, run as Spring Boot app. Okay, now if you can see here, Spring Boot application is up and running. Now what we'll do, we'll do some changes to our Spring Boot application. So go to hello world controller, and here what I'm going to do is I'm going to just remove this REST endpoint that we have added, right? I'm going to remove this and just focus on the console here. Okay, once I remove this REST API, and then I will just press Ctrl S to save this file, and if you can see here in the console, the server will get automatically restarted. Okay, the server will automatically get restarted, and the changes will get automatically reflected. For example, if I try to call this REST endpoint, this won't be available because we have just removed it. Okay, so let's take one more example. Let's say we have a REST endpoint, hello REST endpoint, and if we make some changes in this REST endpoint, then the server should be automatically restarted, right? So what I will do, I will make some changes here. I will just remove hello, I will just remove word, and I will keep hello here, and I will just remove this word. Okay, and if I save this file, and if you can observe the console here, so look at here, Spring Boot application is restarted again. And if I go to browser, and if I just calls hello world, so this should gives me not hello world. If I call hello, so this should give me hello, because we have done changes here to the existing REST endpoint. So earlier it was hello world and we had a changes from hello world to hello. So this is how we use Spring Boot DevTools dependency. Okay, so this will give you a developer better experience, guys. So whenever you develop Spring Boot application, try to use Spring Boot DevTools dependency, so it will save your time. You don't have to restart your Spring Boot application again and again whenever you do some changes in your project. Well, in order to add security to our Spring Boot application, first go to the pom.xml file and let's add Spring Boot starter security dependency. Let's go ahead and let's add a dependency here. Artifact ID is Spring Boot starter security and group ID is org.springframework.boot. So this is the dependency that we need to add in order to provide a security to our Spring Boot application. Well, this dependency basically internally download all the Spring security related libraries. So look at here, it internally uses Spring Security Web, Spring Security Config and EOP and other dependencies. We need to add only Spring Boot starter dependency, Spring Boot starter security dependency, and this dependency will take care by adding all the Spring security related libraries and the compatible versions, etc. Alright, now once we add dependency to our Spring Boot application, next we need to enable a debug log to our Spring security module so that we can able to understand the default configuration of Spring security. Well, just add logging.label.org.springframework.security equals to degub. So this is the property we need to add in application.properties file. Alright, now what we will do, we will run our Spring Boot application and let's quickly explore the default Spring security configuration in our Spring Boot application. Go ahead and just run Spring Boot application. So look at here, as soon as we start our Spring Boot application, then in a console log we can see the statement using generated security password followed by random generated ID. Alright, so this ID is nothing but a password, random generated password. Well, the Spring security by default provides a user with this random generated password, and we can use this default user to authenticate to our application. And one more important point is, by default Spring security enables security to all the URLs in our application, and we need to whitelist the required URLs in our application that we'll see in our upcoming videos. Just remember 2 points. By default Spring security provides a user whose user ID is user and password is this random generated password which is printed in a console. And the second point is, Spring security by default enables security for all the URLs in our application. Okay, now let's head over to the browser and let's try to access one of the REST API. Go to the Chrome browser, in a new tab just type localhost 8080/API/posts. So just we are trying to retrieve all the posts by using this REST point URL. Hit enter and look at here, as soon as we try to access a REST API, Spring security will navigate to us to this screen. So this is the default login page provided by Spring security. It's awesome, right? We have just added a dependency, that is Spring Boot starter security dependency, and we are getting a lot of functionality. Like this is the out of the box login page provided by Spring security, and this is called a form based authentication. Well, let's go ahead and let's enter a username as user and password. We can simply grab it from the console. Just go ahead and copy this password and go to the browser again and enter password in a password field and hit sign in button, and there we go, we got a response of the REST API. As soon as we logged in or sign in to the application, then we can able to access REST APIs. So this is called a form-based authentication. Now we logged in using user and password from the random generated password in a console. So we can also standardize the username and password by using some of the Spring Security provided properties. So let's go ahead and let's add few properties to standardize the username and password and a role. Let's go to application.properties file, and here just provide the properties to configure standard username and password. So look at here, spring.security.user.name. So this is the property that we can use to specify the user. So I'm going to just call it as Ramesh. And we have another property, spring.security.users.password. We can specify password here, and we can specify role as well. Let's say admin. Alright, so instead of using the default provided user and password, we can also provide our own standard user and password by using these fields. Well, let's go ahead and let's rerun our Spring Boot application, and let's try to log in using these credentials. Go ahead and run Spring Boot application. So notice that in a console, the random password is not printed. So as soon as we provide a standard username and password by using these properties, then the random password is not generated in a console. Alright, now let's go ahead and let's use these username and password to authenticate our application. Now let's just refresh, and this will navigate to the login page again, and just enter username as Ramesh and password as password, and hit sign in button. And there we go, we have successfully logged in to our application, and we can able to access the REST endpoints. Alright, we have just entered username as Ramesh and password as a password. So this is how we can provide our own standard username and password instead of using Spring Security provided user and password. Before deep dive into Spring Data REST, let's first understand what is the problem Spring Data REST module solves. Okay, so in typical Spring MVC project, we typically create a controller layer, service layer, and a DAO layer, right? And in controller layer, let's say if we want to create a REST endpoints for employee, then we need to create an employee controller, and then we develop a REST endpoints for employee. Okay, and similarly in service layer, we first create an interface, employee service, and then we create a class employee service IMPL, which implements employee service interface and implements all its methods. Okay, so for single entity, let's say employee, we need to create 3 files. Okay, and let's say if we want to create a REST APIs for other entities like department, project, company, users, etc., then we need to create a controller, service interface, service class for each of these entities. Alright, so if you can observe the code, only the entity name is changing over here, and rest of the code remains same. Okay, so we are basically repeating the same code again and again. Alright, so we can think the solution for this problem. The solution can be automatically creating a REST APIs for a entity. Okay, we are only changing the entity name here, but if you can see, the code remains same. Okay, so that is the problem that Spring Data REST solves. Okay, so Spring Data REST module is a solution for this problem. So basically Spring Data REST uses interfaces which extends JPA repository, and Spring Data REST creates a crude REST APIs for entity for free. Okay, so basically Spring Data REST helps to minimize the boilerplate code required for controller layer. Alright, so I hope you understood how Spring Data REST solves the problem. Well, probably you know that whenever we develop or enterprise application, we need to deploy our application on different environments, right? For example, we need to deploy on QA environment for testing, we need to deploy on AVT environment for end user testing, we need to deploy on production environment, right, for customers, right? So in order to deploy our application on different environments, we need to implement profiles in our application. Well, Spring provides profiles concept. So with the help of Spring provided profiles, we can configure our Spring Boot application to deploy on different environments. So let me show you how to do that. Well, go to resource folder. Within resource folder, we have application.properties file. So in case of local development, we have used this file to configure all the MySQL details, Hibernate properties, and JWT properties, right? Let's say we want to deploy our Spring Boot application on production environment, then we need to change this application.properties file to configure production environment related details. Similarly, let's say we want to deploy our Spring Boot application on different environments, for example, QA environment, then we need to change this properties file to configure QA environment related details, right? We are here basically changing this properties file as per the environment, but basically we don't want to change this file. We need to implement profiles. So let's go ahead and let's implement profiles in our Spring Boot application to deploy our Spring Boot application on different environments. So let me show you how to do that. Go to resource folder and we have application.properties file. So go ahead and copy this file, okay, and paste it here and just give properties name something like application-dev. So in order to deploy your Spring Boot application in development environment, then you can go ahead and create a file something like application-dev.properties file, and you can keep all the development environment specific configuration in this file. Similarly, let's say you want to deploy your Spring Boot application on production, then you can create a production specific profile here, application-prod.properties, and you can keep all the production environment specific configuration in this file. Okay, so similarly, if you want to deploy your Spring Boot application in QA environment, then you can go ahead and you can create a profile or properties file something like this, and you can keep all the QA environment specific configuration in this file. Okay, so this is how we create a property file specific to environment. So whenever we run our Spring Boot application, by default Spring Boot will refer application.properties file and it will read all the configuration from application.properties file. But we want to deploy our Spring Boot application on production, so we need to tell Spring Boot that Spring Boot should read a configuration from application-prod.properties file. So in order to do that, we need to activate this profile, production profile. So we have a property that is spring.profiles.active property that we need to add in a application.properties file. So let me quickly add that. So look at here, spring.profiles.active equal to prod. Now prod profile is activated. Well, once we run our Spring Boot application, Spring Boot will refer application.properties file and it will read all the configuration from application.properties file, and then it will see the activated profile. Now in our case, prod profile is activated, so Spring Boot will go into this file, application-prod.properties file, and it will read all the configuration from this file. Okay, so if you activate dev profile, then Spring Boot will first read application.properties file, and next it will also read this file. Okay, so whatever the common configuration you have in your Spring Boot application, then that you can define in application.properties file, because this file is invoked first, and based on the activated profile it will invoke corresponding properties file, in our case application-prod.properties file.